Uh, can you write an equation like x plus some constant times y equal to some constant? Write these such two equations of your desire.
Fine. Hello.
Yeah.
Uh,
So
we have some instructions for from sir. Please go
right,
ahead.
right, right. So we'll continue and we'll just give a brief explanation of why what a matrix is, how we come to a matrix, why we consider it as a function. So Praneeth, can you write two equations? Oh, sorry, Sriram, can you write two equations? Another equation, 3x plus 4y equals to something. 3x plus 4y equals to say 5, right? So we have two equations. These are linear equations, and we can represent these in uh, in the form of a matrix. So we can take the coefficients of the variables and put them in a matrix. So can you write that 2, 2, 1, and 3, 4? Yeah, 2, 1, and 3, 4. And we can take the variables themselves in a column vector. Right. Can you scroll to the so we can write the variables x and y. So if we have two matrices. So we have a matrix 2 cross 2 matrix and one 2 cross 1 matrix. So if we multiply these two matrices, we will get that equation, right? So 2x plus y and 3x plus 4y, right? So if we multiply these, we will get the equations that we had. And yeah, correct. So now we have a matrix 2 comma 1 and 3 comma 4. We are multiplying it with some variables. Those variables are my input. Those variables, the column vector represents a vector itself. So suppose if I give it an input of 2 comma 1. So suppose I have a matrix. Can you write, Sriram? 2, 1, 3, 4. Can you write a matrix? 2, 1, 3, 4. Okay. I am giving it an input 1 comma 2, right? Everybody, I hope everybody knows what matrix multiplication is. But even if you don't, uh, just understand that once we have two matrices, we can multiply them and we can get some output. We'll come to that what matrix multiplication is. We'll come to that later. But as of right now, you should understand that we have two matrices. We can multiply them to get an output. So our output in this case would be 2 into 1 plus 1 into 2, that is 4, and 3 into 1, that is 3, plus 4 into 2, so 11. So 4 comma 11 is our output. So we have a matrix, we gave it an input, we got an output. What is the basic definition of a function? So if we go to the high school definition of a function, we know that a function is something that we give an input to, and in return it returns us an output, right? So we gave this matrix 2, 1, 3, 4 some input 1 and 2, right? And we got some output 4 comma 4 comma 11. If I give it some another input, it will give me another output. I don't have to do anything. I just have to multiply this matrix with my input and it will give me an output. So can everybody see that my matrix is acting like a function? It's not a function that you might have studied in high school, like a quadratic function or a mod function, but by definition, it's acting like a function. It's modifying my input and returning me an output in return. So if does somebody, okay, can you guys raise hand if you understood why we consider a matrix as a function? And you can unmute and tell if you didn't understand this part, why we consider a matrix a function. You guys can go ahead, unmute yourself if you haven't understood why we consider matrix as a function. Okay, I hope okay, even if you can't unmute yourself, you can type a message in the chat box. We can see that if you have not understood why we consider matrix as a function, or if you have understood, you can put that in chat as well. That I have understood.
I have a small point to make here.
Yeah.
I think to me, I'm finding it difficult to look at matrix as a function, even though I understand where you're coming from, is the fact that we are looking at it as numbers. Because function generally you look at it as, okay, it's going to be doing something. It's taking the inputs and outputs. It's generally does something. But here,
Right.
since we are looking at the matrix as some data, so it makes it a little bit more difficult for us to visualize it as a function. At least for me, that's personally, that's what I feel.
Okay. So let's not consider this as even a matrix. Okay, let's just forget about that we have a matrix. Suppose we just imagine that we have something, we are giving it an input, and in return we are getting an output, right? So that part should be is clear to you,
Yeah, that's
right?
correct.
So okay. Now that you've understood that what the basic definition of a function is, now we'll come to this matrix. So we represented two equations as a matrix. Two equations as a matrix. We gave it an input of a vector, and in return it did something. I don't know what it did, but it did something, right?
Yes.
So it did something, and it gave me another vector in return, right? Can you see that I gave it an input of 2 cross 1, right? 2 cross 1 matrix. I gave it an input of 2 cross 1 matrix. It gave me an output of 2 cross 1 matrix.
Yes.
Right?
Yes.
But it changed it. It changed the value. So I gave it 1 comma 2, but it returned me 4 comma 11.
Yep.
Correct? So it did something, and it returned me something else. I gave it something else, it returned me something else.
Yep.
It transformed it in some way. So isn't it acting like a function? Now think about it. The definition we discussed. Forget about why we are doing it, why we are writing a matrix. Forget about that. Just think of whether we can consider this as a function or not. I gave it an input.
Yeah, I think I agree with what you're saying, right? When we define the function as something which takes an input and then transforms it into an output, I think from that perspective, it's pretty clear, right?
Right.
What I meant was where it gets a little confusing is because when we look, one thing is okay, because we have never been used to looking at matrix as a function. The other fact is okay, and also we generally tend to okay, I can't say we, I at least generally tend to think as function as doing something, not as data. So I think that's what makes it a little bit unintuitive for me at this point of time. But I think I clearly understand why you're calling it as function.
Okay. No worries. You just follow the session, and I think you'll get some more clarity as to why we are considering this as a function.
Yeah, thanks.
So
okay, wonderful. So what I'll do is for some time, I will, okay, mute everyone for the time being. When you raise your hand, I will, co-hosts can unmute themselves. Okay, perfect. Perfect, perfect. Others, I am not letting them unmute because there may be many people joining us now. Just in case they do, I want to ensure that there's no chaos. All right, so it's a Sunday evening. Very, very, very glad to see that there are 50 students on Sunday, where it's a culture in many of the developed countries to push off in the mid of Friday, calling it a weekend. And in India, every day is a holiday. Every meal is a banquet, as they say. In fact, by every day is a holiday, I mean we enjoy every day as a holiday. We work every day. It's not that we have special days which are off. And it's very heartwarming to see so many people around on a Sunday evening. Wonderful. So with this, maybe we can close the whiteboard for the time being. Okay, perfect. Perfect. And I want to quickly request everyone to volunteer for a couple of tasks. Can someone please copy paste my message on Discord that I posted? We need a lot of volunteers to stay organized, nothing else. We can continue this session of discussion like for the next few months to come, years to come, but then it helps to be organized in the sense that we make notes, we record lectures, which I'm ready to come forward to record some very to the point lectures. It's like you saw my website, right? There are some module 1, module 2, up to module 5 questions are ready. I'll be posting them soon, but then it's ready in the iPad handwritten format. It will be nice if someone can transcribe that. It will be nice if I will record the question to answer. If someone can slice it up and then put it on the website, it will be wonderful. All this at the cost of roughly 1 hour per week per volunteer. If I have some 20 volunteers, it's like amazing work can get done. And it will be for Coders Eye, by, for, and of Coders Eye, right? So please come forward. That's basically a big call from my side. For points 1, 2, 3 in the chat window, I need a few dedicated volunteers. By dedicated, I mean someone who can promise X hours of time every week. This X hours won't be beyond 1 to 1.5 hours per week. And it will be announced in advance and your task will be clearly described. This kind of help is what will keep our Coders Eye initiative rolling. Some of the tasks involve 1, 2, 3, converting handwritten notes to typed version. 1, 2, I'll be creating videos and the volunteer should annotate the video and create a table of content. This is a straightforward job and is easy to do. I'll give a short tutorial for roughly 10 to 15 minutes, 20 minutes, and you will be able to do it like a pro. Maintaining the website, you just need to know some basic HTML or Markdown language, and rest is obvious. Let me know if anyone is interested in any of the above 3 points. I suggest that you specialize in one of the above 3 only so that you're good at it and it will make less and less, it will take less and less of your time. Of course, everybody is responding here. It would help if you join the Discord link, which I pasted just now, and then go to the volunteers channel and then propose to help us out. I suggest that you don't be in all 3. Take up one of the 3 points and then do well there. And it will not make it take a lot of time. It will be very organized. We will be doing very good contribution to the Coders Eye community this week. All right, so with this, let's start off today's discussion. Matrix as a function was a discussion. I must tell you all, the very idea of seeing matrix as a function is for convenience, because that is something that we don't see it in our school days or college days, right? Maybe it's not motivated that way for some reason, because the coverage of syllabus is the idiom there. You just finish the questions, not worrying about why it is interesting, why it is required, right? But then matrix originated because people saw it as a function. Historically speaking, they saw simultaneous equations. And then they realized that, why not stack it up and see it as a table? And this table was actually a function, as Chetan was beautifully explaining. What was that, Chetan? 1, 2, 3, 4, xy giving you something, right? Seeing it as a function helped. But then someone was asking this question. That's a very good question. We also see matrix as data. When you see it as data, let's say an image, which is a matrix, you don't see it as functions. You don't have to see it as functions. You should not see it as functions. On need basis, you play your cards. But It will be wonderful if we can see matrix as a function as a beginner, because that is how the story began a few centuries ago, by seeing simultaneous equations as a function from this side to this side. And is it invertible? Right? Can we come from this side to this side? What do I mean by that? A matrix on XY giving you something. What's the pre-image? It's one way of asking a question about simultaneous equations, while there are many ways to solve simultaneous equations. Today, we're going to take up a slightly advanced topic. Advanced is only at the level of symbolic manipulations. Otherwise, it's a straightforward idea. The idea is just this. You are in city A, okay? But your office, or let's say your child's school, is in city B. All right? In city B, you cannot have a house. You can only have your house in city A. But your school is in city B. Where will you buy or rent a house? Obviously speaking, the nearest point on the boundary of A. So commonsensical. This is one of the sort of an ultimatum idea in linear algebra, which helps us solve certain things that are otherwise not solvable at all. We'll be discussing that today. Okay. Chetan, are you familiar with GeoGebra?
A bit, sir. I haven't used it extensively, but a
Okay.
bit.
Okay, no problem. Anyone else here who is very familiar with GeoGebra? Raise your hand. Okay. So if not, I will illustrate. I'll just ask a question. Again, I repeat, in all our discussions, we ensure that we know the theoretical minimum. We don't assume a lot of math, a lot of understanding. So today's discussion will involve high school mathematics only. Three-dimensional geometry of high school only. Okay. In high school, we don't study a lot of 3D geometry, at least not in my syllabus. So you all are forced to think according to my syllabus. If you are to blame my teachers, my state syllabus. All right. Okay. So now let me start a calculator 3D and then share the screen with you all. Meanwhile, you people also initiate GeoGebra and share the screen with me. Is it visible? Can I see some thumbs up? Go to GeoGebra and click on 3D calculator. I'll give you people a minute's time so that you can do this. I hope you all are done. Here, let me draw a small plane. You see, I can move around this. The sleeping axis, as you know, the sleeping plane is like R2 sleeping. We're adding an extra dimension. Right? Okay, perfect. So I will put a plane here. You all know how to include a plane. 2x plus 3y plus 7z is equal to 0. Okay. 2x plus y plus 4z is equal to 0. Okay. Type this and play around with this. Let me maximize this so that it's nicely visible. Okay, now you all are able to see the plane, right? Okay. And let me take a point 2, 2. I got the point. That's the point A, right? Okay. You all might know this. Please note, there are different types of people here. People who have cleared JEE, people who are very familiar with 3D geometry, people who are not. I am going to start off with only 8th standard math. With that, I'm going to ask you a question that is really very advanced. And we're going to go till the end. Many of you will realize at some point that it is not as easy as what it started off with. So bear with me. If this sounds very trivial, it means your life is going to get complicated very soon. All right. So here is the plane. Here is A. All of you, please put a thumbs up if you can do what I have given here. Okay. Let me choose a point so that it's easy on the mind. This one is not very easy on your mind, simply because x plus y equals z. 2x plus y equals z. Okay. What is the nearest point to A from this plane? If this plane is a city and A is your school, where will you buy a house? On to you all, discuss for 5 minutes and I'll get back. Okay, some of you know this question already, some of you don't. Do not, very clear request, do not worry about the equations. Do not worry about the math here. Use GeoGebra, draw a perpendicular from A to the plane, not with the equation. There is an option there. Figure out, draw a perpendicular and find out the point on the plane. That's all you got to do today, nothing else. Okay, I'll come back in 5 minutes. Go ahead.
Can anyone show me how to input this individual point here? This plane we definitely do, but
Ankit, somebody has written in the chat box. Just write 2, 2, 2.
okay. If someone is not having access to system, I have just shared a link to access this GeoGebra, the same drawing that Sir drew. And try rotating it, seeing with it on different angles and see that what, just think that what is the nearest point on the plane on that is nearest to A. And is there some of property that we can use it to identify it. Just think.
Sir, your screen share is on.
Is anyone like some of you have pasted it in chat window that it will be perpendicular distance from a point on the plane. So anyone is having trouble understanding this point? Means how it's perpendicular to the plane that is nearest to the point.
By perpendicular, do you mean perpendicular to y-axis or perpendicular to plane?
Perpendicular
Perpendicular to
plane.
plane.
Like we are finding a point that is inside a plane, but is still nearest to A. So what property does this the point on the plane should have so that the distance to the point is minimum, point A is minimum?
It should be straight below the point that is present.
Yeah, but and what do you mean by the straight below the point A?
So it would be at 90 degrees. The line connecting those 2 points will be at 90 degrees. Right?
Yeah, that's the idea. Yeah.
Somebody had raised their hand. I missed that. Who was that? Okay, no issues. No issues.
Okay, one of you can share and then discuss quickly so that we can go ahead.
Chetan, would you like to go ahead?
Yeah, yeah. Is my screen visible?
Yeah, it's visible.
Okay, perfect. So this was our equation, right? This was our plane. This is the plane visible to everyone?
Yep, that's visible.
Okay, perfect. And we had a point that was A, that was 2, 2, 2 in the 3D space, right? In the R3. So the question was that where should that person buy their house so that it's the closest to this school on this plane? Somebody correctly mentioned in the chat box that you can draw the perpendicular distance on the plane from the point, and that would be the closest distance from this point to this plane, right? So if we draw a perpendicular line, you can see that it's intersecting this plane at a point, and that point is your answer. Wherever this line is intersecting at this plane, that point is your answer that's the point where that person would buy their house so that it's the closest to this school. If somebody has any doubts with this, they can unmute themselves and ask that question.
So why perpendicular is the shortest distance?
Right. Nice question. So what do you think should be the shortest distance? Maybe you have something or some alternative in mind.
If if in a okay, we are in a R3 space, but if we took any one, if we consider any one dimension, let's say in X, we are very close to X, so we should focus on X only instead of considering the 3D dimension.
Okay. Could you consider an alternate example that is easy on your mind? Like you are sitting inside your room at this moment. Is there means if you are looking at your ceiling fan and you are finding the nearest point from the floor that is nearest to your ceiling fan, what do you think this point would be on the floor?
I just want to know what's the shortest part according to you. Maybe you have something in your mind. Maybe that can help us understand why that is the shortest part and why perpendicular distance is not the shortest part. Maybe you can give us some idea, and then we can discuss that.
I mean, like I was saying, in the perpendicular distance, we are traveling through the 3D space, right?
Correct.
So, at the same time, we are like instead of going into the whole 3 direction, this is the example. But what if we have some shortest distance just in one dimension only, like even instead of going this way, perpendicular, we can travel into the x axis only. And
Interesting. So you're saying instead of going this way, you're saying that you want a line that is in the x direction, right?
hmm,
So that should be what
You can just put a perpendicular line to the means y is equal to z, y
yeah,
z
yeah,
is equal to plane and
right. So
point and plane. Z equals 0 because he's talking about x and y.
you're saying the plane should be
Just make z equals to 0. That's the equation of plane, na?
is this what you're saying? Sorry. Ankit, can you repeat yourself?
Yeah, just define another plane that is defined by the equation that z equals to 0, and just draw a perpendicular line from A to that plane.
So you're saying another equation where
Z equals to 0.
hmm,
Okay, now you have got a base plane. Now you draw a perpendicular line between A and this plane. Point and plane. Yeah. That's okay. Now we need
that's
yeah, okay, but
not the okay. So
we just need to change the equation of line now. Means when z and y is equal to what 0 means y and z is equal to 0, then you will go for x.
who was okay? Mukesh, is this what you were saying?
Yeah.
So it's in the okay. So let's forget about what we know about equations and everything. Just graphically, can you tell me which line do you think is the shorter one? Which do you think is the longer one? Just graphically. I'm not even asking you anything else. Just graphically tell me which line do you think is the shorter one?
To be honest, it is hard to say. Like to me, both seems equal. Like maybe I have to try in my like on my PC.
Chetan,
Do you
just rotate this plane means a bit more in this left side, so that he has his eyesight is along the plane itself.
all right, right.
Yeah, Yati has given a very good analogy, you know.
Mhm.
You have got a wall in front of you. What do you think would be the your nearest point on that wall? Are you supposed to look right side, rightwards, leftwards, or just in front of you, or upwards or downwards? Which would be the which would be the shortest distance from your eyes to the wall?
Correct.
So it
So
is going. If you are going to deviate from something, anything other than perpendicular, you know, it is you are going to cover more distance intuitively only.
right.
Leave alone the equations and the results.
Also, another
Calculations.
idea that we can think of is that this forms a right angle triangle. Any other,
Correct.
you perform another line, and then you form a right angle triangle. So no matter what line you put, it will become the hypotenuse, which is the longest
Correct.
side.
Right.
Yeah,
That's
that we
why I
can.
was asking the question that which line do you think is the shorter one here?
Yeah.
That was the only motivation because you can clearly see since this is the perpendicular on this plane. That's why I rotated in to the top so that we can see this whole plane as a single line, and we know that this orange line is the perpendicular.
Yeah. Now it's
Right.
clear. Thank you.
Okay, perfect. Okay, does anyone else have any doubts about it? That why the perpendicular line is the shortest path from a point to a plane? Or any other doubt with this? So we have a plane, we had a point, we needed to figure out what's the shortest path from this point to this plane. Because wherever that path intersected with that plane, we are interested in that point. So that was our motivation.
Can you all simply try this? First one is the plane itself, 2x plus y plus z equals 0. You get the plane. And then a point 2, 2, 2. Don't worry about anything. We are only talking about the nearest point on the plane where you would like to put your house if your office were to be in A. As simple as that. And that intuitively is the perpendicular distance. Or better even, if this plane were to have that ability to gravitate and an object is falling from A, where will it fall? It will be a vertical drop onto Earth, right? For that, maybe I have to modify this plane and make it, okay, sleep like this. And for that, I'm going to deform this entire figure, which I'm not going to do. I'm going to keep it back to its original position because a slight deviation disturbs it, as you would have realized already. Okay. All right. So, and then what I'll do is I'll take A equals 2, 2, 2, second point. And then third one is perpendicular line between A and equation 1. And you get this black line. And then I say intersect equation 1 and F. These are two objects. And GeoGebra gives you minus, what is that? 2 by 3, is it? Minus 2 by 3, 2 by 3. And that's the point. That's it. Okay. Now, patiently look at this question. All of you done with this? Put a thumbs up if you have understood. Put a virtual thumbs up so that I can count. Okay, very good. Now, let us quickly take a look at our Baker's problem. I will share the screen. Look at question number 2, module 2. Look at, is the screen visible, Srivinay, Anurag, Nishan?
Yes.
Okay.
Yes, sir.
So, module 2, question number 2, 3, 4. And we'll stop at 4th question and see this 4th question is what we just discussed. All of you, I repeat. Look at question number 2, question number 3, question number 4. Forget question number 1 here. Someone post the link on the chat window.
So it's already there. Ankit.
Okay, wonderful, wonderful. So question number 2, 3, 4. 2, 3, 4, 5 maybe. Don't go to 6 and 7. Only 2, 3, 4, 5. And see that 4th question is exactly what we solved just now. Numericals are different. The numbers are different. Otherwise, it is exactly the same problem. That's all is the wisdom you must carry for today. Otherwise, the class is over. But the advanced part of it will continue right now. And those who thought it's all obvious so far will see some hardcore maths today. All right? But otherwise, if you can see, after reading question number 2, question number 3, question number 4, and you realize that question number 4 is what we tried on GeoGebra just now, give a thumbs up to yourself, pat on your back. We are done for the day. And if you want to know more, stay back. Otherwise, you're good to go. Right? On to you people. I'll give you 10 minutes. Figure out how the 4th question is same as what we discussed just now geometrically on GeoGebra. On to you all.
Guys, let's observe these 3 questions in the question number 3. Anyone have idea? Can we get a specific value of A and C for this?
Okay. Ankit, before we jump to the question number 3, I think we should start with question number 2. I think that would be a better idea.
Yeah, sure.
Before we move to a complicated question, we'll start with the simpler one. So can everyone see the second question?
Yeah.
Okay, perfect. So can somebody read that question and tell us what's given in that question?
So yeah, it's that
you can unmute and share your doubt. You have raised your hand. This Arpreet.
Go ahead, Arpreet.
Let's go ahead.
okay. So I hope we are able to hear
Tell
me.
his only back.
We encounter questions very often in our lives.
Okay, let me share the screen. Let me share the question. Just give me a second. Okay, is the screen visible to you?
Yeah, it is.
Perfect.
So okay, we encounter equations very often in our lives. Consider, for example, the following situation at Baker's Cafe. The manager has a very important estimate to make. Mostly visitors at his cafe happen to be families, and they are often comprised of children and or adults. He observes that there are 3 children and 3 adults and 1 child at a table, and their bill turns out to be 1,200 rupees. There is yet another table with 2 children and 1 adult, and their bill turns out to be 1,000 rupees. Can the manager estimate the consumption of a child/adult This is popularly called as simultaneous equations, and we all remember from our school days multiple ways in which this can be solved. So what they are saying is exactly is they are for just giving two equations like three. There are three adults and then one child. So you get a bill for that 1,200 rupees, and then two child and one adult consume like 1,000 rupees worth of stuff. They want you to find how much one adult can consume and one child consumes. So they are saying, okay, this is simultaneous equations. As you can see the equations that are given below. 3a plus 1c is 1,200, and 1a plus 2c is 1,000, and you can solve it obviously.
Yeah, perfect. Right. So in the question, we were given that there are 3 adults and 1 child at a table, and the bill turns out to be 1,200, right? So that's and we converted that, we wrote that in the form of an equation, that is 3a plus 1c equals to 1,200, right? It's what I'm seeing intuitively in the question, right? That we wrote 3 adults, 3a, 1c, 1 child equals to 1,200, correct? And similarly, another equation, 1a plus 2c equals to 1,000. And somebody has already texted in the chat box mentioning the values of a and c. What should be the values of a and c? I'm pretty sure that most of you know how to solve two simultaneous equations. You've been doing that since high school days. You subtract the equations, you substitute the values, and you get some value of a and c. Correct. And we also saw that how we can write these equations in the form of matrices. Correct. We saw that. Okay, somebody has a writing aid.
I'll do
Shrikant,
that.
are you here? Okay, yeah. Go ahead.
So whiteboard.
Yeah, perfect. Whiteboard will do it great. And guys, we appreciate if you can participate. You can explain what you are thinking about the question. What do you think should happen in the question, or what do you think we should do with the question? That would be great. Okay, perfect.
So everybody will have to follow me, I guess, or everybody is
Right.
allowed to write.
Okay, so in the question, we had two equations. Just write. Let's write down those two equations. So one was 3a plus 1c equals to 1,200. 3a plus 1c.
If everybody could just set aside their mouse.
Yeah.
Somebody is
right.
writing as the same time I'm writing.
Okay. How?
Anyways, everybody was just keep their mouse on the right side. Yes.
Right.
Whiteboard is gone.
I'm so sorry, I closed it accidentally. Maybe you can share it once again.
Yes, sir.
Nishan, instead you can open a Zideboard or something so that
Right. Nishan, can you open the Zideboard?
Okay, I'm doing it.
That would be great.
So new Zideboard, or should I log in?
Create a new Zideboard. I mean, if you want to export it, you'll have to log in. But yeah.
Okay.
we can use it.
You can click the eraser button twice
Yeah.
to clear. There's an option to clear the board.
Where?
The erase button.
What should I do? Just
Click it again.
okay. Fine. Anyways, this is somehow, something is related to B. I'll write down the equation. 3a plus 1c (1a plus 2c). Fine, we have two equations as given the question. Fine. So the question is, what if there are more equations than variables? That situation can well, be a reality, because we cannot have only two customers visiting us, two families visiting us eventually. We'll have a lot of data, many families visiting in many permutation and combinations. So there is well a possibility that one adult and one child visits and spends a total of 900 rupees. Fine. And now we have to find the solution of these three equations, the best possible solutions. Fine. So what do we make out of it? What do we, as a data scientist, we are given the task to find what would be the best possible quantity of A, and C. So what would we say? What would be our answer? Given these two equations, what was the answer? Can somebody say? Tell us. A is equal to? Am I audible? Okay, so what was the answer? A is equal to?
$150.
Okay. A was 150. C was?
$750.
Pardon?
750.
750. Okay.
That doesn't seem right.
No, I think it cannot be that.
It's I think A is 280 and C would be 360. Yeah.
280 and 360. Fine. What if this third equation comes in,
It is not getting satisfied in the third equation.
Pardon?
These two values are not satisfying the third equation.
Exactly. Very obviously, 280 plus 360 is not equal to 900. So what do we make out of this situation? Because it's a very obvious thing. Many families would be visiting in many permutation combinations. Fine. That would make a lot of equations and less number of variables. That's a very obvious situation. But as a data scientist, you are given the chance, given the task to find out what is the best possible solution to the baker. So what would be your answer? Anybody?
Maybe you can find the point where 3a and 1c and 1a and 1c, leave out the second equation and solve for the first and the third. You will get another value of a and c.
Fine. Okay. A barabar something we get and C is equal to something we get when we solve equation 1 and from equation 1 and equation 3.
Yeah.
Fine.
And do the same for 2 and 3.
Fine. Okay. Afterwards?
Now we can get some average value, I guess, like, add these three and then divide by 3. So you'll get some, approximation of, how much an adult ate and how much a child ate.
So you are suggesting that we should solve for, take average by solving two equations at a time.
Yeah.
Okay.
All the three, two equations at a time with all the three equations.
So what is your motivation behind pursuing this approach?
Because I want to ensure that I consider all the equations. That's all. Like
So
each family.
simultaneous equations has a very good, very rule defined from very early edges that variables and number of equations have to be same if you want to find a solution to it. What you are suggesting, if you draw graphs in GeoGebra, is that you find many solutions and make a draw some kind of line through the best average kind of line, which is best fitted line.
Yeah.
Is it? Okay. So that does not give us exact value of A or C.
Yeah, it doesn't give the exact value, but it gives the best approximate, I guess.
So don't you think not finding the average though, but don't you think that we were just discussing that when we were discussing the nearest nearest point to a plane by finding a perpendicular distance from it?
Yeah.
We were doing only that.
Yes, we were.
We were doing only that.
Just consider this point also. A few minutes back, we all agreed that the point on this means if we are finding some solution, then that has to be the nearest. Here, the nearest values are 1200, 1000, and 900. How can you be sure that if we are plugging in AS 280 and CS 260, then that point will be nearest to 1200, 1000, and 900? Consider this point.
The question, what you are meaning to say is, if on plugging A as 280 and C as 360, we get that the point which is nearest to all three equations. Are you saying that?
Yeah.
Yep.
But I don't think so, because 1A plus 1C is equal to 900 it will be farther away from that one stuff. But if we take the average, it will be near to all, right?
But for what values are you taking average?
No, that's what I told. So you solve two equations, two simultaneous. You take two equations. So you take equation 1 and you take equation 3, and then get the point where they meet. So since equations are lines, we can think of them as lines in GeoGebra. So where two lines meet, you can take that one solution. Another solution where the two equations 2 and 3 meet, and then 3 and 1 will meet. So you'll get three different points. Or at least maximum three different points. So if you get three different maximum three different points, you can find an average, that is add 1 to 0.1, 0.2, 0.3 by 3, and then you get the average. So the average, it denotes that okay, that point is somewhere near, all close by to all the points. That is the closest point to all. It will be close to all the lines. I think you get it. So if we have 3 points, let's
okay, like are you writing on a screen, Nishan?
Sure.
Can you just draw any two random points on this, like A and B? Just any 2 points, A and B, in this Cartesian system only.
Fine. For example, A, we are here, and B, it is here.
Yeah. Now just draw a dotted line that joins A and B and extend to infinity to infinity.
Fine.
Now write a P dash point that is towards the side of point B.
What should I write?
A point P dash that is towards the side of B, means shifted towards B.
Okay.
Plus
Here.
infinity. Plus, yeah, anywhere will do.
P dash.
Yeah. Now, what you are saying is, if we are taking average case for the point A and B, then that will be something on, means what you are visualizing is something between A and B. But now consider if we are changing just B, where can you ensure that average case is giving you the best results?
What I actually meant was not between just A and B. So let's say that this P point is a solution, right? P is a solution. And then A is another solution for, 1A. A is a solution for 1A plus 2C equal to 1000 and 1A plus 1C equal to 900. So if you solve these two equations, you get a solution which will keep as A here, the A in the line. Okay. And then you solve equation 3 and 1. That is 3A plus 1C equal to 1200 and 1A plus 1C is 900. You solve those two, you get some value. You get one particular value of variable A and variable C. So then that you represent as a point B here in the line. Now you have these 3 points B, A, and P. That is 3 solutions you have. This is the maximum case. Okay, there can be 2 solutions, but let's take this is the my worst case. We'll take 3, and
Okay.
then now add all the x coordinates of A, B, and P, and then take the average. That is divide the thing by 3, and then that is the x coordinate of the point. And then similarly do the same for y coordinate. You'll get the y coordinate. You will get another point. Let's say x in middle of A, P, and B. So that point will be equidistant from A, B, and P. Am I right?
No, but how do you ensure like, okay, if you are getting picking 2 equations,
Yeah.
as you say, like first, second,
Okay.
third, plus 12.
Ankit, we'll go ahead. That was it's important that people discuss in detail. I'll quickly go ahead and then tell you today's theme, which is, let me write down the equation from my screen here. Just bear with me for a minute. Here you go. Okay, so what was that? 3, 1. Am I visible? Is my iPad visible? No, right? Okay, wait a minute. Wait a minute. Okay. Three, 1, 1, 2, 1, 1 times AC is equal to 1200, 1000, 900. All eyes this side and all ears this side. Okay. This is the question, right? Am I right, Chetan? Can you just put a thumbs up just to ensure that there's no printing mistake in what I've written? Okay, perfect. So now, here is where we give a different meaning for matrix multiplication. This is same as A times 311 plus C times, excuse my bracket, which is not symmetric. Okay, is equal to 1200, 1000, 900. Put a thumbs up if you all understood it. I believe most of you understood this from the discussion that you people were having, but still put your thumbs up. A times 311 plus C times 121 is equal to 1200, 1000, and 900. Why am I writing like this? I want to see this question as this question. Both are same questions, in fact. 3A plus C can be written as A times 311. That becomes 3A, A, C, 2C, C is equal to so and so. I can write it like this. This is same as, let me write that down. Let this sink into your minds. This is same as 3A times the 0.311, correct? Plus C times the 0.121 is equal to the 0.1200, 1900. What do I mean by this and this? What does this signify? This signifies the linear combination of 311 and 121. This fellow is simply the plane passing through three one one, 121, and of course the origin. And I'm saying this should be equal to tada. This may not be the case. This point may not be on that plane. By the way, you got to really have a keen mind to see the transition from here to here. If you're not able to see, maybe you should work through it. Any combination of 311 and 121, one of you can show it on GeoGebra. What will happen if you take all possible linear combinations of 311 and 121? What all will you get? You will get all those points on a plane passing through 311, 121, and origin. And is 1200,900 on this plane? Obviously not. You can again see that using GeoGebra. But then my question is, which part of the plane is closest to this point? Yeah.
Hello. Sir, how you get the point 000?
Yeah, that is for you people too. Now you guys will discuss that. Okay. What is the nearest point from 1200,900 to this plane? The word plane, where is it coming from? You're right. The word plane, why is plane coming here? Zoom on this. Spend some time on this. Discuss this for a couple of minutes. And we'll see more of this. Okay, we'll have only 5 minutes so that we can go ahead. Okay. I have shared this note with everyone. Maybe Chetan, you can share the link with everyone on the chat window. Do you have it or shall I share it?
It would be nice if you can share the link. Okay, I have the link, sir.
You have the link. Okay,
Yeah.
Sure. Scroll down this link and you will see what was written just now. This takes some time and you all should work through it. Call this the exercise problem of the day. Write it. And guys, from here we'll go to QR factorization. From here we'll go to least squares method. From here we bring in transpose of matrix. Things get very messy, but at the end, the climax is a beautiful, quick solution for modern computing question across engineering disciplines. Long story short, understand this. Go ahead.
Okay, somebody had asked why we have written that 0, 0, right?
I would like to ask him why other points are written at the first place. What is
Pardon?
different about other points which 0, 0 and 0 don't have?
Okay. I couldn't understand you properly. I couldn't hear you properly. Nishan, was it clear to you? Nishan, Ankit, did you understand? Did you guys understand what we said?
Can you please repeat, Nitin?
Yeah.
Oh, sorry, Arpit.
Arpit, can you repeat what you just said?
Okay, anybody? Can somebody?
I think he said why the other 2 points, like other than 0 0 0 we wrote the first two column vectors, right? 3 1 1 and the other point. So why we wrote those points? That is the question.
Yeah.
Can I ask it out?
Yeah, sure. Why not?
Actually, I missed the initial discussion. Can you please tell why are we looking at the point with the foot of perpendicular to the plane?
Actually, we are deliberating on the question number 2 of module 2. Fine. Do you have that link of module 2?
Yes.
We are deliberating on question number 2 of module 2, and afterwards 3, 4, and 5 questions that are related to question number 2 only. Eventually, you'll find similarity between those two questions. And actually, this question is also that only,
No, but can you please tell how is it related?
Yeah, we will come
Yeah.
to that.
That is that is what we are trying to do now.
Okay.
That is what we are trying to establish, that why they are similar.
Can you tell how this plane represents, how this turns out to be a plane passing through 3 1 1 1 2 1 and 0 0 0? Anybody?
Guys? So this was our question.
Let's show them it in GeoGebra, because it will be easy to visualize it.
So we had
Maybe.
guys, can you see the screen?
Yeah, Chetan is back.
Okay, sorry.
Yes, Chetan, yes.
Can somebody else share the screen? I have a power outage in my area.
Yep, I guess Srivnay will.
K plus 1C.
Okay. What just happened? I just.
So you have to 3A plus 1C equals 1200. This was our first equation. Second one was 1A plus 2C equals to 1000.
Why this is happening?
Use small case, I guess.
You can.
It's taking some.
Oh yeah. We need the 3D calculator for this. Right.
Okay.
Yeah. Let me send you the link for 3D calculator. Just a second. Yeah.
There you go. No? 3D calculator. Fine. 3A.
I have created this plot and the link, share the link if you can. Yes.
No, I will just do it.
Okay, sure.
1200. No. Okay, sure. I'll just
That's it.
copy paste the link in that. Yes, Chetan?
No, go ahead. Go ahead.
Yep. Okay. Sorry. So this is. I'll just dim everything. I'll go step by step. Fine. So the question was, how does the sir ask this question? How does through 1000 it represents a point. So this is a green. I'll rotate. A is the yellow one, green one is the B, and we have a solution
So
of
the linear combination darken this hue that you are seeing.
Use the linear combination of both.
And draw a plane also, no? Regular plane. I don't know which file you just.
Use the cross product, no?
We are not discussing cross product. We are just saying that we are trying to visualize this picture, that is the combination of this two vectors, that is 311 and 121, where else we can reach. And is it feasible for us to directly reach to the targeted point, that is 1200, 1000 and 900 from there itself? So we are analyzing this point.
But linear combination of A and B should lie in the plane of A and B, right?
Nishan, should I share my screen?
Better share your screen, because my computer is kind of hanging because of sharing and opening up this whole thing at the same time.
Is my screen visible, guys?
Yep.
And let's go from the basics for this question. This is your just 3D plane that we just open using this 3D calculator on GeoGebra. I just plotted these two points that suggest what this
311 and 121.
311 and 121, that you can just see here. These are my 2 points that you can see. Is it visible now clearly?
Yep.
Now you can see that what we have right here as this thing, these two vectors as a linear combination of A times C 311 and C times 121. So similarly, I just defined two variables, C and D, by the name of C and D. And if I take their linear combination, this thing, that is the rod, you see that where we can go from this thing. But plane that I have defined, like look, it is 0, 0, 0, and it is from the point A and from point B. Now, if you try to vary this, just the scaling factor itself only, you can see that you can reach almost anywhere on this plane that is defined, that is characterized by the points A, B, and 0, 0. You can reach anywhere. Now, if you can just open it and visualize it through the link that I have shared. Now our targeting point is 1200, 1000 and 900. That is quite big for us to easily visualize. Make a point of say from h equals that as 12, 10 and 9. I think I just set up h is to 12, 10 and 9. Is this just like
Zoom out a bit.
Zoom out, zoom out.
Just a minute. This point H also H. Now see, where the plane is their linear combination anywhere going to this point. Is it feasible for us to reach from the linear combination of point A and vector A and vector B to this
Point
point?
H.
Is it feasible? Comments anyone?
It's not. It's not.
It's not. So now comes the idea that we discussed a few minutes back, that it is a plane. Their linear combination of vector A and B forms a plane. But we cannot achieve the right hand side, that 1200, 1000 and 900 from the combination of these vectors alone. So what is the nearest point on this? What is the point on this plane that is linear, nearest to the vector h? And that we saw that it will be perpendicular. And can you give me a hint how we should draw a perpendicular from this h to the plane? Go ahead, please. I'm saying that can you visualize this perpendicular drawn from the point h to the plane itself? We have point and a plane. The point is h and the plane is
Linear combination.
H is a point or a vector? You take as a point or a vector?
Yeah, we need to define that then.
Yes, sir. Somebody was asking whether H is a point or a vector.
Yeah, like in the definition of H, we have defined it as a
What
H.
we see, if the point in a space when connected through 0 becomes a vector, isn't it?
Yeah.
So H is a point, since we are representing it in the form of matrices, it's turning out to be a vector.
No, in that finding while finding that perpendicular distance, it is a function which takes a point, right, and a plane.
Okay.
GeoGebra, in the GeoGebra, that perpendicular line you're trying to find it. That like that function takes two inputs. One would be point and another would be plane. So should we define H as a point?
Yep. Ankit is doing that only.
I'm having trouble. Can anyone give me a hint?
No, he's saying that just write a point P.
Capital letter for the variable. Yeah, that's one. Now it will become a point.
No.
Yeah, 12, 10, 9. Yep. Now draw perpendicular.
Perpendicular line. Point and
plane. Huh?
And plane we have
Linear combination.
Just rotate the plane.
Are you guys able to see that? And
increase the value of C and D, no?
Yeah, sure.
No, I think GeoGebra can only plot until there. It's like that's
No,
the
no, you
end
have
of.
to just zoom out, I guess.
No,
No,
we
no, no.
can.
Okay, that is the limit of GeoGebra, minus 510, huh?
Not to visualize, to the plane is being visualized only in that place, but yeah, it does go to infinity on both sides. So we can think of it. That it's actually entire space.
Okay, okay, okay. So we can
Zoom
imagine
out, what
that.
happens? What happens when you zoom out from the page? Are you able to zoom out?
Yeah, we can zoom out.
Now I think it'll happen. Yeah. That's...
Now you see that suitably adjusting this points, we can definitely reach the point A. Not point A, the point that is on the plane, but intersect this perpendicular line. And if we go here and
We cannot go to.
no, we are not going to A. We are going
At the point of intersection.
at the point of intersection. So suitably adjusting, because we just saw that their linear combination can make us transfer to this plane anyway. But so if you suitably adjust C and D, we will reach this point, that is this one. Perpendicular intersects this.
Where a perpendicular intersects the plane. Maybe just write down that point as well. No?
Yeah, that
point P, point to some point, write a point X maybe. That is an intersection of plane and line.
Can we define that?
We can try. X is equal to.
We would have to calculate that first, no? Yes.
I guess GeoGebra can do that, no?
Can GeoGebra do that, guys?
Try. Maybe try now.
Yes, just right. Now let's go for, we don't have this name, then point and vector or list. No, we cannot. We only have the option for object, parameters, vectors, and list from and point list. No, we cannot draw this point. We can see that suitably adjusting these points, we can reach all the points that are on this plane. Like you can see that we are moving somehow closer and closer to.
Yep.
Okay. Okay. An important point to be noted. Simply guessing the values of A and C will give you a fantastic way to solve this problem. How will you guess? Simply take some A and C and then keep bettering it. All right. This method is popularly called the gradient descent. We'll give you the details. But then where we should reach from here is what is called the least squares method. Forget about what is it called. The idea is you find that perpendicular drop in a proper linear algebraic way. And the moment you reach there, your knowledge of linear algebra would be perfect. This is going to come in module 3. I was just watching you all discuss. Looks like the crowd is not yet prepared because you don't understand how A times 311 plus C times 121 compares of a plane. You see, we'll cover all those questions in the upcoming module 3. So what you do is next week completely work towards understanding linear algebra in 3 dimensions. All right. And I'll be writing down what all I'll be covering in the upcoming weeks. First point, importance of A and A transpose, which we again saw yesterday. Please note, yesterday, today, day before and all, these are all warm-ups. They may not appear connected, but they will soon get connected with time, right? So A transpose, we will see the importance of dot products. V transpose W. We will find the perpendicular drop from a plane to from a point to a plane, which is what we are seeing, we will see a very powerful idea called the Gram-Schmitz process. Don't worry, this sounds very complicated, but it's very easy. And the encompassing factorization of A, which have been tempting you people from a long time, A equals QR, and the connection between this problem and this problem. And finally, what is coder's high without some coding? Code and solve Baker's Cafe's problem with a million equations and a million variables. Maybe we will not say million, maybe 10 variables. We had only adult and children here. We'll have adult, male, female, child, boy, girl, age group wise division, and you will get more variables. And we'll see how we can solve this with some coding. All right. So that's pretty much it. I don't think you guys are ready for further discussion, but that's okay. So we can stop here. Others can continue your discussion if you want. The notes is ready and saved. We will look at this in detail in the upcoming classes. And with this, I think matrix mystics can come to an end. After this, we can move to data structures maybe. And after that, we can move to some data sciences ideas, some 10 ideas I'll explain, which involve some standard ML algorithms. And maybe after that, if time permits, we can take up more modern computing ideas by the end of this year. And for all these things, I'll be giving you notes. I'll be giving you videos also. What I'm doing right now is slowly as I'm explaining it to you people, I'm making notes on how you people understand, how you people don't, what exactly are the hiccups in understanding. And based on that, I'm working on notes, sequence of questions, and also video material that are very focused. What I discuss right now is impromptu, but I'm soon coming out with some very focused lecture notes plus lecture videos. Please stay tuned. See you all tomorrow at 9 p.m. Take care. Feel free to continue discussing. The Zoom session will be open. Thank you. Good night.
Thank you, sir.
Thank you.
Have a good night.
Thank you, sir.
Okay, so can we discuss what we were discussing earlier? The questions, question number 2, 3, 4 from module 2.
Can somebody tell, how does that make a plane? Somebody, who was not, participating in the discussion, somebody new. How does, that thing makes an equation?
Yeah,
Some
actually,
scalar time a vector. Yep.
The query is related to the same, but I was I was not ready to look at that as a 3D. That's the problem. Why we are looking at it as a 3D? That's us to query. Like,
See, as the number of variables increase,
the variables in the sense like there are two variables. Equations are getting increased, but the variable remains constant. Yeah.
The variables are same, of course. Variables are 2 only. Eventually, they can increase. As I told you, there can be as many as you're going to discuss as many as 10 variables while coding.
What he wanted to understand is how we are drawing this equations as a column vectors in this plot, because he got the idea that there are certain x and y, a number of variables. But now he's asking why are we able to draw it in 3D? Then the representation of vectors, I think we should focus to address this.
Okay. So he's saying that how does 3, 1? It is very obvious that 3, 1 represents a vector, isn't it? But he's saying that how come we take 3, 1, 1 from set of 3 equations and declare it as a vector, isn't it?
Okay. So can
It's
somebody
not
write a
exactly, it's a
matrix?
column picture.
Oh yeah, we will come to that. So can
So
somebody write a matrix on a whiteboard? Can somebody share the screen, write it down? Maybe we can take that approach of multiplying it with a uh, I cap, multiplying it with I cap and J cap. Maybe that might help some people understand why we're considering them as vectors, why we need a R3 plane to represent those.
Does anyone have this mouse in something?
Yeah,
I have
I
it,
do.
but that has started, to hang. My computer started to hang. I was writing. I'll retry maybe, maybe
Okay.
whiteboard would, suffice.
Yeah,
I'll try once again whiteboard.
actually, I don't have mouse. That's why I was asking that if anyone.
No, not an issue. I have this thing. Okay, and yep. So what are you saying? Yes, Chetan?
Yeah. So let's take a matrix 1, 2, 3, 4. Okay.
1, 2, 3.
No. 1, 2, 2 and 3, 4. 1, 2 and 3, 4. Okay, Swapnil can.
Okay. 1, 2, 3, 4. 1, 2, 3, 4.
Right. So we have 1, 2, and 3, 4, right? A matrix, or in this case 1, 3 and 2, 4, right?
Mm-hmm.
How do we represent a vector on x-axis? A unit vector on x-axis. Can somebody answer that part?
yeah, 1, 0.
Right. Also,
Unit
we
vector.
right. So we represent that as 1, 0. Can you?
Everybody is trying to write on whiteboard. Please, everybody stop writing and let only one person write.
Shrivana, can you help us out with this? Can you write on the whiteboard?
Yeah. Okay. Sure.
He starts writing with mouse, and I found out that it's really difficult.
No, I'll do one thing. I'll do one thing. I will try to stop sharing the whiteboard for everyone. Only co-hosts can share it. That way,
Okay,
Nishan,
yes.
you can do.
Yes, sir.
Thank you.
Okay, we're restarting. Fine. So should I restart the whiteboard maybe? Isn't it?
That's a good idea. Maybe, yeah, because
I'm restarting the whiteboard. How can I start?
Just sorry. I restarted the whiteboard.
Restart the whiteboard.
Okay, no. Some unknown error.
or it's better we can go with Zideboard. It's so simple, right? Why?
Yeah, use whiteboard.
Okay, can you share the whiteboard? Ishan.
Yep. I'm opening Zideboard. There is a lag in Zideboard actually. Maybe I'll write on Paint and share the screen. That would be better because there are two online things.
Yeah.
Is my screen visible?
Yeah. It's visible.
Okay. Okay, let us start here. Okay. This is not lagging, and Zideboard was lagging actually because the Zoom is also online thing and that is also online.
Okay.
Fine. Yes, Chetan. Let us.
So-
We are saying that we are going to make a matrix. Fine.
Matrix. We're
A.
going to take a unit vector on x-axis.
Matrix was 1, 2, 2, 3, right? 1, 2,
Right.
3, 4.
Right.
1, 2, 3,
3, 4. We are giving it a input of a unit vector on x-axis.
So this is x-axis and this is y-axis.
Right. So we're going to give it an input of 1, 0. That is my vector or unit vector on my x-axis. So we discussed how when we considered matrices as functions, right? And we discussed that when we give input to a matrix, it gives us an output, and it does something to that input. It gives us some output after doing something to that input, right? So if we give it an input of 1, 0, so it should give us another matrix of 2 cross 1. No, a column vector of 1, 0. A column vector of 1, 0. Yeah. So it will give us what? So I hope everybody here understand matrix multiplication. If somebody doesn't understand matrix multiplication, they can raise their hand and they can tell us. Okay. So when we multiply these matrices, what we are going to get? We are going to get 1, 2, right?
Yeah.
Correct. So our 1, 2, we can see it represents a vector on x-axis, right? That it is our I cap here. Correct. If we take another vector on y-axis, 0, 1, we are going to get 3, 4, right, as output. So if we have 0, 1, we give it an input of a unit vector, we are going to get an output of 3, 4, a vector of 3, 4. So we can see that it did something to the unit vectors on x-axis and y-axis. It transformed them and it returned us back, right? So
Yes.
it scaled this matrix scaled them and it returned back two vectors, our I cap and our j cap, right? So can we see that our column vector 1, 2 is actually our I cap here in the matrix, and our column vector 3, 4 is actually our j cap in the matrix. Can we see that?
Yeah, we can surely see that. I think Nishan, can you highlight that with some blocks? Maybe it will be even more clear. We can clearly see that the 1, 2 in the column is what is coming is A the first time, and the 3, 4 in the second column is coming as the answer.
Right.
So
Correct.
yeah.
So we have two vectors in our matrix. Can you draw the column picture of this, Nishan? Can you draw the column picture of this matrix 1, 3 and 2, 4?
1, 3?
Yeah, the matrix 1, 3 and 2, 4. Can you draw the column picture of this so that everybody understands why we are saying? Yeah.
1
So
by
this is 1, 2. This is our I cap, and then we. Okay. Ankit, Shrivana, can any of you take over from here? My network is unstable. I'm having power outages here.
Take over, I guess.
Hello. Hello.
You want me to go ahead?
Shrivana, Ankit, can any of you take over because I'm having power outages here.
Yeah. Yeah. Okay.
Shrivana, please you take. I don't have any writing tools.
I can go ahead. I can go ahead. No worries.
Yep.
Okay. Yeah. So okay. Initially, what everyone has to have in the back of the mind is that a matrix is a function, right? And why I say that the matrix is a function maybe might not be clear now right now, but maybe as Sir said, it's for ease of representation or ease of working with whatever we have. So in this case, what are we looking at the matrix? Right? When we look at the matrix, so did you delete the entire thing? Okay, that's fine.
Yep.
I could have used that. It's fine. So when we saw what are we doing when we apply? I mean, we kept a vector next to the matrix, right? And we try to understand what happens when I multiply that matrix with that vector. But essentially, what is happening, right? Think of A as a function which takes two inputs, right? If you think of A as a function, can you write f of x comma y is equal to a comma b? No, small a and small b. This is a function, right? What is this function doing? It's taking two inputs, x comma y, and giving us the output a comma b. So when I want to think about this in terms of matrices, because I'm thinking of a matrix as a function, right? That function is taking two inputs. Let's think of the inputs as xy, right? So 1, 2, 3. So I'm applying the function 1, 3, 2, 4 on xy. Can you just write that down? 1, 3, 2, 4 on xy. Yeah, 1, 2, 3, 4 maybe. Yeah, 1, 2, 3, 4. When I'm function actually, I'm just representing the function like that. I'm not saying that itself is a function. I'm saying for this function I have to give I have to give an input, and then I can observe an output, right? So let's say I'm giving. Can we remove the f on the left hand side? That's not what it is. That's not how we can represent it, right? Because what is inside the bracket is the input, right? In the above, f of x comma y is the input. Here in the matrix form, when I'm representing the input, I'm representing it as a vector xy.
Yep.
F is the matrix here, right? Because I'm thinking of the matrix as a function. So yeah, so what happens to the output, right? That's what I think about. When I apply this function on this, but on xy, what happens to the output? Let's just say it's a comma b for now. We know how to calculate it, but not a comma b like that. Sorry, a b as a vector, right? That's how it outputs it, right?
A 2 cross 1 matrix, Nishan.
Yeah. A B, yeah. Awesome. Now, I mean, what do we want to understand now? We want to understand.
So somebody had asked.
Function.
No. Somebody had asked why we were representing those three equations in an R3 plane. So in R3 plane, why not as three lines? Somebody had posted that question.
Yeah, it's me. Chitwata has given the question.
Yeah.
Instead, we are having only two variables, but we are just migrating to 3D.
But before that, before we jump into that, we need to understand what a matrix is. So okay. So I see Shriram. Hi. not seen you before here. So I wanted to understand how much of this you understood. I just wanted to ask a few questions, maybe, or I just want to understand how much you know about matrices as a function.
Can you repeat?
Yeah, I just want to know your level of understanding. So, is it comfortable for you to think of a matrix as a function, or do you think? I mean, I can see that. Okay, it looks just like how I'm applying a function, but
Yeah.
what are the numbers inside it mean? I can't make sense of it. Can you make sense of it?
So you know the degree of transformation that you do on the input is what the numbers mean actually, I guess.
Okay.
So
And
for example,
yeah.
you take a point and then from the input to the output, you know whatever transformation that we are doing there, that is converting this point to that point. That is what the function is doing. So for example, if we take f of x is equal to 2x plus 3y, the 2 and the 3, that the coefficients of x and y is what is the 1, 3 there, the numbers there. So yes, it's just a function. It's like the 2x plus 3y. What does the 2 and 3 mean in that? That is what the same, that's the same stuff that we are meaning here.
And I want to understand how you came to that conclusion. Like, is it by looking at the right hand side, saying, okay, because 2 is being multiplied with x, and I mean, in this case, it would be 1 would be multiplied with x, and 3 is being multiplied with y. That's why I think that's what a function, that's what the matrix is doing. That's how you came to the conclusion, right? I think.
Like sort of, like for example, you know, the first class sir explained that 1x, this can also be written as 1x plus 3y equal to a, and then 2x plus 4y equal to b, and then we compare the left and right hand side, and then we make out the 2e. So from there you can just make this out that these are just the coefficients of x and y, and then they are the stuff that form the function. So if you change the coefficients, you are changing the line itself, right? Since you know, a linear equation represents a line. Okay, if you change the coefficients, you're changing the line. So
yeah, okay.
Unless you obviously multiply it by 2 and then do something like that.
Or you just add a constant.